Let's take a look at the step response of a parallel RLC circuit, and in this case we want to find the current due to the application or the sudden application of a DC current. Okay, so meaning at time 0 we open the switch. Okay, so once we open the switch, then we have current coming through this parallel RLC circuit. When the switch is closed, the current is essentially going through this short circuit and no current is reaching the RLC components. So we want to look at the sudden application of a DC current on this parallel RLC circuit. So let's come up with the equations here. So we want to apply, so at t greater than 0, we want to apply KCL at the top node. Okay, and what we'll see is we have V over R plus I plus C dV over dt is going to equal to the source current. Okay, and then from here we can derive the transient response as well as the total steady state response as well as the total response, just as we did with the series step response RLC circuit. But note here, let's step back a little bit and say we know that V is equal to L di dt, and then we can substitute this equation, we can substitute this into the above equation, and we can come up with the second order derivative. So d squared I over dt squared plus 1 over RC di dt plus I over LC is equal to IS over LC. And then we can break this down into our steady state, our transient, and steady state current. Okay, and these are the responses we're going to have. So let's define our I of t for transient, and then ISS for our steady state, and our total is just going to be the addition of all these two. So we add these, we get our total response. So let's go ahead and write these down, break it down into the different cases we had. So let's look at the total response. We have I of t is equal to IS plus A1 e to the S1t plus A2 e to the S2t. This is going to be our overdamped case. And then we got our second case, I of t is equal to our IS plus A1 plus A2t e to the minus alpha t. This is going to be our critically damped case. And then our third case is going to be our underdamped, which is I of t, IS plus, and you see the pattern, it's essentially the same that we've been doing for the previous sections, WDT plus A2 sine WDT times e to the minus alpha t, and this is going to be under damped case. Alright, and we'll highlight this here. This is going to be our total response, and then again A1, A2, this is going to be based on our initial conditions. Okay. for both I and di dt, and then we can get those accordingly as we've done in the past. But this is essentially not repeating all the derivations, but essentially what we need to know for the step response of a parallel RLC circuit. And in this case, we're looking at the current through the inductance. Okay. Next, we'll go over several different examples for the different types of responses, and as well as looking at the source-free series and source-free parallel RLC circuit examples.